Thank you very much for your time. So did you enjoy your lunch? Okay. I think so depending on the people, so it's noon and so getting sleep and sleeper from now. But anyway, thank you very much for your time. I'm Masanori Itoh from Toyota Motor Corporation, and using this time, so I'd like to share the so-called virtual vehicle fleet current status. And about me a little bit. So yesterday too, so I introduced myself somehow, and so this introduction says I'm a double hat guy, but actually, so recently I got one more role, and so nowadays I'm a triple hat but a single page guy, and this talk is from the technical, so-called infotech division. Wow.
Excuse me, that's a very young guy. That's not you.
No,
the guy there.
This guy. Actually, this is me, and drawn by my daughter when she was 3 years old or so. Yeah. So actually, it's a treasure of me. Thank you very much. Not seeing this one. In Japanese, takarabodo. Okay. And so again, my specialty is basically operating system, and I've been working in the open source world roughly 15 or more years or so. Okay, and here is today's agenda. And originally, so when I submitted my this talk, so originally, so I was going to focusing on the virtual vehicle fleet. So the parity infrastructure, but so after that, so I got some situation change, and today, so I put 2 more topics. Sorry, so that's why. So this talk is a very busy one, and also, so I will finish my talk within 25 minutes. Okay, okay. Then let's get started. And at first, so-called virtual vehicle fleet. Okay, and last time, so 6 months ago, so AGL AMM Spring, I gave this talk, and at this time, so I showed 99 AGL VMs are running on top of a single data center rack mount server equipped with not Intel but ARM physical CPU. Okay, and after that, I witnessed the Kusakabe-san is there? No. Okay. So AGL, so SDV Reference Platform architecture, and looking at that, and the primary motivation is like this. So promote data center. So as I'm originally from the outside car things. Okay. So that's why. So I thought it's a good idea to promote data center side virtualization technology adoption to realistic vehicle configurations or needs for rapid development of the vehicle software. Okay, this is a generic idea. And more detailed ideas are like this. So looking at the SODEV architecture, so use the same component with SODEV and build a fleet of virtual vehicles with multiple profiles of ECUs. So here, I mean, AGL has multiple demo images, IBI or cluster or gateway or telematics. And by combining those different profile AGL virtual machines, I thought we can construct a virtual vehicle with multiple ECUs, virtual ECUs. Okay, this is the idea. And here are some components that I want to use. And also, the bottom 2 lines are some additional things that I wrote. And I will show some a bit stupid demo later. And here, the start point was like this. So Kusakabe-san, and if I understood correctly, so Jerry from Panasonic got this inspiration. So build the vehicle HPC system on top of reference hardware using Zen hypervisor and also Zephyr-based control domain and also device domain based on Yocto or AGL compositor, brain things, which access to the hardware actually, and then IBI or instrument cluster or some more. And in case of Kusakabe-san's case, Android OS, or some more ACU, higher ACU required, ECUs were there. But this is a simple version. And by the way, so how many of you are familiar with this cartoon, so-called a tree swing cartoon? So I'm from the system integration business world, and this is a kind of net meme. And actually says, so system integration project, so saying what the customer, so in this case, Sakabe-san originally got the inspiration. This is the one. And often the deliverables is like this, or the sales promise is like this. Okay. No one knows. Oh, exception. So, but it's okay. Sorry. And looking at this original one, what I thought is, I think so folks can guess. But anyway, so by using the data center grade rack mount server with ARM CPU, and also then hypervisor and Zephyr control domain, and then run bunch of AGL VMs. Okay, and then compose multiple virtual vehicles on top of a single rack mount server. Okay, this is what I wanted to do, and maybe in this cartoon can be over promise, or maybe a delusion. Yeah, okay, and so I tried to build like this, but actually the reality what I got is currently what I have right now is like this. So at least for me, so as I'm using Ubuntu for the host system, and I have some technical difficulties, and technically should be possible, but so far what I have is running those AGL virtual machine instances using KVM virtualization. This is what I have, and also, if I drill down the details of this implementation, I built multiple configurations of AGL virtual machines, and also I wrote some very small manager which interacts with the libvirt. This is what I introduced last time 6 months ago, and mainly controls the virtualization infrastructure, such as QEM, KVM, or of course, libvirt is capable of handling Zen domains. Okay, and also I wrote small dashboard like this screenshot, using GTK plus 3.0, and here I'd like to show you a bit stupid demo. Okay, this one. Okay. Actually, right now, so I'm running roughly 15 VMs in data center server located in Tokyo. Okay, but this demo dashboard is running here and as you can imagine, so this RBI screen and also that cluster screen are displayed through the VNC connection. Okay, from Berlin. So again, from Berlin to Tokyo. Okay, through the VPN connection. And in this sense, so as this is VNC, of course, interactive. So right now I clicked HVAC and very slow, but anyway, interactively we can operate this thing. And also, just a moment. Right now, Super Salmon VM is. So these two screens are Super Salmon VMs. And last night, I built a Trout up to the latest release built. And just a moment. Then let's switch to the screen. Again, I'm using the Flutter version of the VM. So appearance is almost the same, but so on the cluster VM, I'm running a simple CAN simulator, and and inputting the CAN data to to this meter applications. So although, again, this is, so physical distance is from Berlin to Tokyo, but still something working. Good, so I think so this is sufficient for this kind of small demo that I think. So that's what I think. And by the way, and also if I switch to another Trout VM, so Qt version, of course I have. And as you can see these VM list, so I put the AGL release version to the virtual machine name. So a kind of mixture of the multiple releases of of AGLs. Okay. I spent 10 minutes. Okay. And then let's get back to my talk. And by using this so-called VVF, so that's what I'm calling this thing. And so I want to step forward to a kind of a POC, a bit large scale POC, like this kind of system configuration. AGL instances are around here and anyway many. And also these AGL instances are connected through the mobile network connection, but emulated ones, okay. And then terminate at so in this case network H1s, and then connect to the cloud side, so public cloud or the on-premise system also. So I want to show, so I want to carry out this kind of POC, so as I will explain again later, okay. And here is some, a bit technical, a bit detailed technical topics, so that I integrated, okay, so far. And the top one is a cellular network, is a software stacks used for the emulation of the cellular networks. Okay. So by the way, so I have already uploaded my deck on my session page. So no need to take pictures. Okay. Sorry, and and also I found, and in order to enable the mobile, emulated mobile network communication, we need some small software, so-called, for example, UE runs in. This stands for, UE stands for user equipment. So simply speaking, like smartphone, okay. And RAN stands for the radio access network. And SIM stands for simulator, but actually, so what this component does is emulation, mobile cellular network communication over UDP emulation, okay. And as I wanted to have this one integrated into the AGL, so I found this, so small Yocto layer or recipe, and in my build, so I use this one. This is one point. And also, in addition to the mobile network connection, so I wanted to work on the observability things, okay? So that's why, for example, eBPF things. So that's why, in order to do so I wanted to have, BPS trace format feature in the kernel. It's not enabled in the Yocto standard kernel. So that's why, so I did some modifications to the local.conf of Yocto. Okay, and like this. And I guess, so I will have some questions regarding the impact of the performance or the resources by enabling this one. And at least kernel image is plus 5 megabyte, and memory footprint overhead is under investigation. But I hope, I think, or I guess it's not so significant, I think. Okay. And also from a viewpoint of observability, if anyone knows what is open telemetry hosted under the CNCF, no one. Okay. But anyway, so there is a standard observability related component, and Yeah, and OTEL core is open telemetry stands for Open Telemetry Collector, and a kind of agent to collect the observability data from the target to the central server. Okay. So, by the way, so these are the details of the current status of the VBF, so that I shared 6 months ago. And the next topic is of diagnostics. So far, do you have any questions? Is it okay to go going further? Okay, yeah. Then, and so I think Kusakabe-san mentioned OpenSOVD, and this is the same thing. Okay. And this and SOVD, and what is SOVD? So simply speaking, so the new kind of protocol enabling a bit improved diagnostics. Okay. And it's defined, originally defined by the ASM. And right now, under the standardization process at ISO, and the specification number is 17978. Okay. And here is the use case defined in this draft of the ISO version of the SOVD. And as you can find, almost similar to the conventional diagnostics such as UDS, but still a little bit extended. For example, discovery means not only just static discovery, but also dynamic discovery, including software, not only just hardware component. This is one point. And also suppose, software updates. Regarding software updates, so I think UDS also support, but look at this one, number 14. SOVD supports script execution. And by using this, we can run some data processing or any kind of processing inside vehicle. For example, HPC or so. Okay. And the schematic would be like this. And so far regarding the diagnostics, I think normally technicians connect their testers through the OBD2 port. But in the specific, in the use case of the SOVD, so it enables tester connections through Wi-Fi network, or in addition, cellular network connection. These are covered, and also full remote scenario is also considered. Okay, and here is some examples of the SOVD REST API examples. Example one is retrieving hardware status data, and the second one is software state data, and the last one is the one that I mentioned in my previous in the previous slide. So issue script execution like this, and also parameters are specified in the request body of the HTTP request. So by the way, so as you can see, in SOVD, operations are defined in the HTTP method like these ones. So compared to the UDS, so I think folks here are very familiar with what is UDS. So binary based, so different from binary based protocol. The ability of expressing these kind of information is very rich. This is a point. Okay. Yeah, okay. And I think Kusakabe already mentioned OpenSOVD, and so it's okay, I think. But Mercedes guys initiated a project, open source project, to implement SOVD at the Eclipse Foundation, and so this month, July 2nd. So we had a kickoff meeting, and there were more. So I was surprised to see more than there were 90 participants. Okay, and right now they open GitHub organization, but it's at this moment it's almost empty. Yeah, waiting for some repositories will be created. Okay, yeah, okay, and this is the third topic, AECC. By the way, so AECC stands for Automotive Edge Computing Consortium. And actually, Murata-san initiated this initiative and activity. Again, like AGL, okay. And and at work, I'm also involved in somehow in the AECC activity. And so at the AECC, using various components that I introduced so far, including, of course, AGL. So I want to carry out some POCs in collaboration with various folks, companies or folks. Okay. And regarding AECC, they released lots of white papers already, and also you can find out what kind of POCs they have carried out so far. And among them, I'm slightly behind. This POC10, so-called POC10, optimized selection for realizing digital twins and green energy utilization. So I helped this POC activity somehow. And also, right now there is a discussion and forming process, but they are going to form several SIGs, special interest groups. For example, number one is data first SIG, but originally this was started from the E2E communication SIG, but anyway, shooting for more flexible and reliable vehicle data utilization, especially starting from the connectivity viewpoints. Okay, and here, from my point of view, retrieving data, vehicle data sufficiently from the vehicle is important, I think. Not just relying on the UDS, but using more advanced vehicle data handling mechanisms like SOVD. And this is somehow a part of my motivation. Okay. And so I'd like to summarize my talk, and this is the topic. So this is schematic summary what I've talked about in my talk, and by combining lots of things. So starting from the AGL SODEV and also some fleet management system and SOVD, new generation diagnostic system, and also 5G stacks. And of course, in the data center side, of course there are lots of cloud native things. So starting from Kubernetes or open telemetry or eBPF. In this sense, eBPF can be also vehicle side there. But anyway, combining these technical components. So I'd like to form. So I'd like to set up a use case and carry out a POC to prove that at AECC. Okay. And this is a recap of the overall system diagram that I showed earlier. Anyway, like this kind of setup. So regarding use cases, so for example, this is just random thoughts under discussion. But anyway, for example, offer location-aware tailored information service to drivers, or the digital twin at transportation hubs or intersections. And regarding the enabling solutions, of course there are lots of things, but anyway, so on-demand device data retrieval via next-gen dynamics. So here I mean the SOVD. Okay. Like these things. So right now I'm thinking about as the next step of the BVF. Okay. And in summary, again, so in this talk, so I share the current status of the virtual vehicle fleet based on SODEV. And a second, so I shared what is SOVD and what we can do using SOVD. And third, so I introduced some ideas of POCs that I'm thinking about, and also so how we can build it. yeah, integrating so AGL, so SODEV. So I forgot to add that one. So SODEV, SOBD, and 5-stack and more, working with external communities widely, and possibly starting from AECC. Yeah, that's all. And thank you very much for your time.
Anybody have any questions?
No question? Okay.
All right. Thank you, Itoh-san.
Hi.
Thank you.
Yeah, thank you very much.